Hi developers, I'm Hussam Dilai, Microsoft MVP. In this video, we'll learn how we can apply dependency injection and inversion of control in Xamarin Forms applications. This will enable us to have an application that is easy to maintain, easy to write unit tests, and also easy to extend. We'll use Unity application block as an IoC container in order to register and resolve all our dependencies. Using dependency injection have an advantage of being able to access the platform specific implementation for each platform. Here from Visual Studio, I started by creating an empty Xamarin Forms application, and then I have added some logic here. So I created an MVVM application where here I do have a model called product. The product have a property name price and a property or a method to string where I show both the name and the price of each product. Then I do have an interface called iProducts service. This interface have a method called getProducts, and this interface is implemented by the class products service. So it implements the getProducts to return a static list of products right here. Those products or this service is used by the ViewModel, which we call it here products ViewModel. So we'll create a new instance of the service, then we'll call our service.getProducts in order to get that list of products and then show it or assign it to our products property. Then we do have our view products page, which here will bind or will use binding context in order to bind to the products view model, and it will try to get that list of products and show it inside the user interface. So if we run the application, then we'll get this this page right here displaying the list of our products. So this is a cool MVVM application. Instead that we have one problem that makes it a little bit difficult to maintain and to extend and also to unit test this application. It is that here it is renewing the instance of service from the view model, which is not good right here, because it will make it really a little bit difficult to unit test and to maintain. And it also violates one of the important principles for OOP programming, which is the single responsibility. So renewing or creating instances here is not the responsibility of this class. So someone else should have done that for it. So let's try to fix this. It would be really nice if this class doesn't create a new instance of product service, but instead it could get an instance of iProduct service from each constructor. So here I'll say I want a new instance of product service, and then we'll go and assign that product service right here instead of creating a new instance. So we say product service equal the instance we get from the constructor. But here, who's gonna create this instance of product service? So this is what we'll do now using Unity IoC Container. So let's go and install or add a NuGet package to our PCL project. For that we go here to our PCL, then we go and right click and say manage NuGet packages, go to browse, then look for Unity NuGet package. Here it is. Let's install that. Once it's installed, we'll start by configuring or by creating the IoC container. So for that here I want to configure it inside the app.xaml.cs class. So I'll go here and create a new instance of Unity container. Let's call it Unity container equal new instance of Unity container. Then this container will be responsible for registering all the instances that we need in our application. So here, one of the dependencies we need here is the products service, because our products view model depends on this interface. So let's go and call Unity Container dot register type. Then register type will ask us for two parameters. The first one is the interface, and here it is iProducts service. The second parameter is the implementation of that interface. Here I'll use the implementation of product service. Let's resolve the namespace. So with this way, we created a container in which we put an instance of product service, and for each or for every call to iProduct service, this container will give this instance of product service. So now let's say that we want to use this container for our application, so that any class in my application that wants to resolve its dependencies, it will use this Unity container. For this, we'll use the service locator, and the service locator here will apply a configuration that will tell our application to ask the service locator for each dependency it wants, and the service locator will use our IoC container here, this Unity container, in order to get that dependencies. So let's use service locator. Let's call service locator, and let's resolve its namespace. Then let's say service locator dot set locator provider, and here we should give it the provider. So let's say here we want to create a new Unity service locator, which will use this instance of Unity container. So let's pass Unity container to that. Cool. Now in each time a new instance of this products view model is created, it will ask for iProduct service, and it will get that instance from the service locator, which will retrieve it from the Unity container right here. But now if we go to productspage.xaml, we can see that here we do have an error. It tells us that there is no default constructor found, and that's because XAML here is expecting a parameterless constructor for products view model, but for now we don't have a parameterless constructor because we have added this dependency and the constructor. So how to solve that? To solve this problem, we have two solutions. So the first one is either to go to the code behind, and from there we can create a new instance of products view model. It will be created from the Unity container, and when creating that instance, all the dependencies will be resolved through the service locator. A second solution is to use the ViewModel Locator, which will get a reference to our products view model through a property, because from XAML we cannot access parameterless constructors, but we can access objects through properties. Let's discover the first solution. So here, instead of using binding context from XAML, we'll go and access the binding context from the code behind. So here inside the constructor of the products page, what I will do here, I will go and say products context equal, I call my service locator dot current dot get instance, And you see here from the service locator, the service locator is the object that we have configured from our app in order to have a reference to our Unity container. So we'll go and ask that service locator to get us an instance of products view model. So this way we get a new instance of products view model that will be bound to this page. Note here that we didn't register the products view model inside the app.cs. We can do that, but it is optional because the products view model is the high level of our objects. There is no other object that depends on this view model, so it is optional for us to register it or not. So that instance will be created with the right dependency from products service and will be passed to this page. So this is the first solution if you are relying on C# in your Xamarin Forms application. Now let's discover the second solution, which will do the binding context from the XAML code, and here we'll use the ViewModel Locator. So let's create a ViewModel Locator from the ViewModels folder. Let's add a new class, call it ViewModel Locator. And the ViewModel Locator here is a public class that will have properties. So let's here create a property of type products ViewModel. So let's create products ViewModel. Let's call it also products ViewModel, and here it will only have a getter. We don't need a setter for this, so let's create that getter, and from the getter of products ViewModel we'll go and return an instance of products ViewModel. We'll get that instance the same way as we have get it right here from the C# code. So we'll access the service locator. Let's resolve that property, then access the current, and we'll ask it to get us an instance of products ViewModel. Now we'll try to access this property from our XAML code. So what we'll do here is that I will create a global property for the locator inside the XAML or inside the app.xaml code. So here inside the application.resources I create a resource dictionary, and from the resource dictionary I'll define global properties that will be visible on all my XAML pages. So let's create here ViewModel Locator. Let's make sure we use the right name, ViewModel Locator, and let's here resolve that namespace for ViewModel Locator. Here I'm using ReSharper, so it adds for me the namespace right here, which is the same namespace used for my ViewModel Locator. Now in order to be able to use this ViewModel Locator from other pages, we need to give it a key. So let's call it here Locator for short. Now from within the products page, we can go here and say binding context of this page will be bound to a source, which is our static resource of type locator. And inside locator, because I do have a property called ViewModel or call it products ViewModel, I'll be able to access that property through binding. For that, here I can see IntelliSense displays for me the products ViewModel. Now if I run the application again, then I will see the same information is displayed on my page. Now in my application I want to use text-to-speech feature, which is platform specific. For that, here I have created an interface called iTextToSpeech in my PCL project. And then I have created the implementation in iOS project. For that, I do have a class called TextToSpeech iOS ample for the implementation of text-to-speech, which is here specific for iOS because here we are accessing iOS API. Now I want to be able to call this implementation or to call this speak method from my PCL code. So how can I do that? So here we'll use the dependency injection in order to pass the real implementation of text-to-speech from the iOS project to the PCL project, or from the native project to the shared one. So let's go to our product's view model and let's right here create a new read-only property for iTextToSpeech. Let's call it text-to-speech, and here we expect we can get an instance of type to speech with the same way we get the iProduct service. So from right here I'll go and say I expect to get an instance of text-to-speech, which here I will use in order to call text-to-speech.speak, and here I'll give it a text, let's say DI and IoC, for example. So now how can we register this instance of text-to-speech? So here we do have two solutions. The first one is provided by Xamarin and the second one is using dependency injection. Let's explore the first solution provided by Xamarin. So here if we go to the iOS implementation of text-to-speech, we can see that right here we are adding this attribute, call it dependency, which will register this implementation of text-to-speech on iOS with the iTextToSpeech interface. So it knows it is implementing this interface and it will register it and will be resolved in each time we ask for this interface. Then, so this is for registering the implementation. For getting that implementation, we can go here, for example, and ask for dependency service. So we do have this static class in Xamarin Forms, and dependency service acts like it is a service locator or an IoC container that have a list of registered instances, and we can get the instance we want. So here we'll say get an instance of type iTextToSpeech. So this way we'll be able to get text-to-speech instance we want. So this is the first solution provided out of the box by Xamarin Forms. We do have a second solution which relies on dependency injection. So here we'll go and pass an instance of this implementation to our PCL project. So the way to do that, we'll go to the app delegate, and from here where we are calling the app to launch the PCL project, we'll go and pass a new instance of text-to-speech iOS implementation. App for now doesn't, it is a parameterless constructor, so we'll need to add iTextToSpeech interface to that constructor. So I'll go and do that using ReSharper, add that constructor to app.cs. So from here, from app.cs, I cannot access actually the iOS implementation, but I'll go and access the interface. So iTextToSpeech, let's call it just text-to-speech. Now that we do have an instance of text-to-speech, now we can register it in our IoC container. For that, I'll go right here and say unity container.register. Here I'm not going to use the register type because register type supposes that I can access the interface and the instance of the implementation, but here I cannot access both of them. Instead, what I will use here is register instance, because here I do have an instance of text-to-speech. So let's say right here I want to register an instance of type text-to-speech. Cool. So now that we have registered that instance, now our view model can retrieve that instance from the PCL project, and that instance is passed from the iOS project. And we can do the same with the Android project. So right here I have created an implementation of text-to-speech in Android, and we can do the same to pass that instance from the main activity where we are calling here the app. So here I can say new, let's say text-to-speech Android implementation. In addition to providing a solution to access platform-specific code, DI injection and IoC containers have another advantage, which is making the application easy to unit test. So now let's go right here to this project, call it tests, where here I have created a unit test in order to unit test my product's view model. So here I'm creating a new instance of products view model, and here I want to pass the dependencies for this view model. So here I have created an instance of product service. So let's pass that one, product service. Then we'll pass an instance of iText-to-speech, but here text-to-speech depends on the native platform. It accesses the native API, so we cannot access that the iOS implementation or the Android implementation of iText-to-speech. Instead, what we do is that we use the mocks, because here we are relying on the interface. We have created here a mock text-to-speech which implements the iText-to-speech interface, and here we can provide the implementation we want for the speak method. So from here we can pass the mock text-to-speech object instead of a native text-to-speech implementation. Then we'll call the download products, and then we'll go and verify if the expected result is the same as the actual one. You can get the code that I used in this video from my GitHub repository. So here, if you go to this GitHub repo, right here you can find in this project all the source code that I used right here. So I hope this video was helpful for you, and thank you.